Alright guys, so what I'm going to do in this problem, I'm going to show you how to write the empirical formula of a compound if what I'm given is just the mass. And as you can see here, I'm given the mass of calcium. I have 0.9 grams of calcium and 1.6 grams of chlorine. So the first step that you need to take in this problem is to convert these grams into moles. Okay, so it's actually really not too bad to do. We've already learned how to convert between grams and moles. So I'm going to take 0.9 grams, and that is of calcium. So I'm going to write calcium right here to make that very clear. And I'm going to crisscross swoosh that. And I'm going to put grams on bottom, because I'm trying to get rid of grams right there. And I'm going to put moles on top. Now, as soon as you see this relationship, grams per mole, you should be thinking about the atomic mass of calcium. And so what you should do is you should go to your periodic table, and what you'll find is that the atomic mass of calcium is 40 grams per mole. Okay? Alrighty, so since it's 40 grams, I'm going to put the 40 on bottom. For every 1 mole, there's my relationship right there. So now what I need to do, I need to take 0.9, okay, and I'm going to divide that by 40 in my calculator, and what I end up getting is 0.0225. 0.0225, and remember my units are going to be moles of calcium. Okay. Awesome. Now I'm going to do the exact same thing for chlorine. So I have 1.6 grams of chlorine. I'm going to crisscross swoosh because I want to get rid of grams and I want to go into moles. So I'm going to put grams on bottom, moles up top. Okay. Go to your periodic table, and what you'll find is the atomic mass of chlorine is about 35.45. Here's where the rounding issue comes up. Don't round that to 36 because that would be way too much rounding. Instead, if you have something that's really close to a 0.5 like this one is, just round it to 35.5 and leave it like that. That's perfectly fine to do. If it's really, really close to a whole number like 39.9, then that's fine to round a whole number, but if it's really close to 0.5, just leave it as a 0.5 so you're not rounding too much. So this is going to be 35.5 on the bottom here for every 1 mole. Okay? That looks awesome. Now you're going to take your calculator, 1.6 divided by 35.5, and what you'll find is you get 0.045 moles. Now, what this relationship represents, remember, 1 mole represents 6.02 times 10 to the 23rd molecules. So really, you can think of a mole as being the number of molecules that you have. So for every 0.0225 moles of calcium, you have 0.045 moles of chlorine. Alright, which doesn't really make sense because we want to have a whole number of that, which we will have in a second. But I'm going to first write this out. The way that we represent that relationship is we use the number of moles, we put that as the subscript. So it's going to be Ca with the subscript of 0.0225. And then we put chlorine, and it's going to have a subscript of 0.045. Now, what I'm going to need to do to both of these subscripts in order to make this a whole number, I'm going to divide both of these subscripts by the smallest number, which in this case, as you can see, is 0.0225. Okay, so I'm going to divide because I want these to be whole numbers, and the easiest way to do that is to divide both of these by the smallest subscript. Okay? And let's see if that works. Well, for Ca, it would be Ca, and it would be a 1 because 0.0225 divided by 0.0225 is 1. And for Cl, if I take 0.045 and I divide it by 0.0225, what I get, hold on one sec, 0.045 divided by 0.0225 is 2, perfectly. So that is quite lovely. I've got whole numbers here that looks like something that looks very familiar. You've got calcium chloride there. There is your empirical formula, and you're done. So as you notice, you take something that looks absolutely foreign to you, and by dividing by the smallest number, you get something that looks actually pretty dang familiar. So that's one of the simpler ways of finding your empirical formula.